Hello everyone and welcome back. Today we have 1-to-1 best time to buy and sell stock. It says here you're given an array prices where each price is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choose a different day in the future to sell that stock. And we are to return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So if we look at the examples here, looking at the second one, if it is such that whenever you buy on a future day you cannot sell in order to make profit, you return a 0. Otherwise, you logically seek the lowest price to buy, which comes prior to a higher price, and then return the maximum profit. Okay, so the most intuitive way to solve this solution actually is simple but takes a few extra iterations and a little extra space, but it is worth going over. Okay, so what if we had an array and we were trying to optimize what's the best buy price up until that day. So at 0th day we really only have one option, which is 7. Then we have 1 is less than the previous. The next day is 5, but the previous day is less, so basically it maintains itself, and it looks like for the remaining days 1 is indeed the lowest you can buy for. Now, what about sell? Well, sell should come after the buy, so we start from the end and say, okay, 4 is our only option, but how about now 6 is? Okay, and then 3, but 6 is higher. We want to optimize the sell price, so it becomes as such, and in the end, and then 7 is greater, but that is also the buy price, and it does say that the sell price must come in the future of the buy price. Then if we go through the profits, we see that we cannot do on the same day, so we start on the second day and say if we buy for 1 and sell for 6, our profit is 5. And then we check, we can put this here, we check the profits going forward and return whatever is the maximum. So here profit is 3, 5 beats the 3, we ultimately return to 5. But this takes multiple linear steps, and as you can see, O of n space as well. Okay, so can we do better? And we can. The way we can approach this is by doing a one pass. So essentially what we did here was we tried to optimize the buy price and the sell price. Well, we can actually do that just by doing this, where we start from some point, and let's say we start with the only value we have. This one is our buy. We start the buy at the only value we have, which is 7. Okay, and then we iterate every sell. So let's say starting from the beginning, we can say every value that comes afterwards can be a potential sell price. Okay, and we are also tracking the profit, which to begin with obviously starts at 0. So let's do that. Okay, so now we check. All right, is this sell price less than the current buy price? If so, you know what? There's no profit to be made. Let's just update our buy price. Okay, so buy price is now 1, and we can move this guy to here. Now we're at 5. Now, is our sell price greater than our current buy price? It is. Okay, in that case, what's the potential profit? The potential profit is 5, the sell price minus the buy price, which is 1, which becomes 4. Okay, and then now we move our pointer here. This is our new potential sell price. Our buy price remains a 1. The potential profit is 2, which is less than the previous potential profit, so we do nothing and we move on. Now we're here. Okay, our potential sell price is 6. Our currently still the best price to buy is at 1. 6 minus 1 is 5, and this profit beats the previous profit. So let's update that. Okay, and we're at our last day. Our potential sell price of 4 minus the buy gives us a profit of 3, which does not beat the current profit of 5, and that is indeed our answer. And this allows us to do in, first of all, constant space. We use no extra space, we just use variables, and in a single iteration. Okay, so let's convert that to code, shall we? We did buy. We initialized it to whatever the first price's value is, and we initialized profit to 0. And all we did was we iterated for a cell in the range. Let's see, for cell, so buy price, and this is the sell day. For cell in the range of from the second day, so that's 1, until the length of prices, we can say if the sell price is less than our current buy price, then we want to update it. Okay, so if the sell price, which is prices of the current day, sell day, if that happens to be less than our previous buy price, then we want to optimize for that and then update our buy price to whatever our current day's price is. Okay, there we go. Otherwise, and actually, let's do it like this. Prices of day. Just so we're consistent. So if the sell price is less than the previous buy price, we update buy to whatever today's price happens to be. And we continue. There's no sense in trying to calculate profit when there is none. All right, otherwise, if that doesn't hold true, that means the current day's price is greater than the previous buy price, and there is potential profit to be made. So our current profit will be whatever is greater of either its current previous profit or the sell minus the buy. So this is today's potential profit compared against the current best profit. And at the end, we can just return profit, just like that. Let's check it out. And let's try submitting. And there we have it. All right, once again, this was 121 best time to buy and sell stock. Thanks so much. Happy coding. See you next time.